معكم الأستاذ الدكتور فائز علي راشد الحمد، أستاذ في جامعة بابل، كلية تكنولوجيا المعلومات، قسم أمنية المعلومات. محاضرتنا اليوم تحت عنوان The Weed Numbers with Some of Their Magic Behaviors. هذه المحاضرة أو هذه العنوان أو الانفورميشن تعطى لطلبة الماجستير والدكتوراه في تخصص الرياضيات وأنظمة المعلومات والتشفير أيضا. نبتدي مع the first question. What are the weed numbers? First of all, to introduce the weed numbers, we have to understand what are the prime numbers and what are the natural numbers. Where the natural number is the smallest set in algebra or in mathematics in general, which start from 1 and goes to infinity. Then, if n is positive integer, we define the function, arithmetical function called sigma of n, denoted the sum of the divisor of n, i.e. sigma of n is the sum of divisors of primitive divisors, اللي sigma d sub n of d. Then we say that if n, sigma of n equals d and n, then we call the n number is perfect. If sigma of n greater than 2n, we call the n is a bounded number. If sigma of n is less than or equal to n, less than, not less than or equal to n, is called deficient number. All these concepts, perfect, bounded, deficient, are concepts related to the sum of divisors of that n. Anyway, for instance, suppose that n equal 12, then sigma of 12 equal 1 plus 2 plus 3 plus 4 plus 6 plus 12, and generally will be 28. This number, which is 12, is called a bounded number. Now, if n is called semi-perfect, then n must be the sum of all or sum of their proper divisors equal that n. For instance, the number 12, sum of its divisors will be 6 plus 2 plus 4, and this will be 12. So the number 12 called be semi-perfect. By the way, the usage of weed numbers and prime numbers and all these concepts related to the distribution of number theory and the usage of them actually they use for description or decryption or in cryptography anyway. Now, we define the number in number theory, we define the weed numbers. We call n is weed number if sigma of n greater than or equal to n, but the sum of its proper divisors not equal to that n. That means if we have a number n related to natural number and we know the divisors of that n equal, for instance, 12 is a natural number and their divisor is 1, 2, 3, 4, 6, 12. So if 12 will be a weed number, then 12 must satisfy the following conditions. There is no sum of proper divisors equal to 12, but this is not whole because as I mentioned before, 2 plus 4 plus 6 would be 3 plus 3 plus 6 plus equal 12. So anyway, the first number, the first weed number, or in this subject must be 70, which is the last weed number, satisfy the following conditions. With the condition I have to revise it. The number must be sigma of n greater than 2n, okay, which is the sigma, the sum of proper divisor of 70 would be 74, and there are no sums of proper divisors or all of them or some of them equal to 70. Okay, the smallest weak numbers is 70, which has a proper divisor as 1, 2, 5, 7, 10, 14, and 35. This sum is to 74, which is greater than the number 70. Anyway, there are no sum of part of these proper divisors, or all of them equal to 70. So 70 is the smallest weak number in the weak numbers. Now, we give a sequence of the first weak numbers in our life, which is 70, 836, and so on, as I mentioned in the screen. This opens several problems where some of them solved and some of them still unopened problems. Here we give an overview about some of them. Problems. Do you think that the weak numbers are infinite numbers? Well, the answer of this question must be infinite number. Must be infinite number, and we can prove it. Another question. It's obvious to the reader that the smallest weak number is 70, which is uneven number. The question is, are there an odd weak number? Well, this is still an open problem, and all the general form of weak numbers mentioned in advanced papers, which is related to 2 power k plus product by primes. So any number started from by 2 multiplied by another numbers must be even. So it's difficult to understand what's going on in the weak numbers, but we can say it's till now there is no one can prove there is an odd weak numbers. Another question: are there a general form of the weak number? Of course, there are two. Till now, there are two general forms related to the different paper. We can mention it later. Furthermore, how far away between the respective weak number when n goes to infinity? That means, are there a actual gap between the respective weak numbers? For instance, if we say the distribution of primes, which start from 2 and 3 and 5, 7, and so on. So we can say the gap between respectively primes, it's there is no one can control it. Well, in similar way, there is no one can control the gap between the gaps between the relative weak numbers. Okay, we call weak number n is primitive weak number if none of its proper divisors are weak. We find a general form of them. So we have a natural number. There are several number in natural number, which is the smallest set in reality, starting from 1. In the natural number, there are prime numbers. There are a semi-perfect, there are a perfect, there are a deficient number. So there are several functions called arithmetical functions. Now, some of these functions can count in the primes, which is called, for example, pi of x. Some of these functions can count the natural number, which is called the n of x. And there are several open problems came from dealing with these numbers. So one can see the distribution of natural number so easily. In fact, it's not easy. It's not that easy. It's very difficult to understand it. For example, when we mention the weak number, there are several conditions to get the number will be weak. So the first weak number started from 70 and go to infinity. There is no one can control the gap between these. So in the security of websites, security of networks, security of neural networks, security of any security algorithm, where they use the prime in their codes, one can give a strong condition to let them to prevent the hackers from break down this algorithm. One can use the weak number or primitive weak numbers, and this give a very strong and solid algorithm. So the first usage of the weak numbers is to make sure that your algorithm, as a security algorithm for websites or anywhere, must be solid and strong. The another user for that can use it for as an applicable part in graph network, for example, to solve a real problem in the real life, and we use it for our project with our PhD students as a team project. Many questions. One can ask a common question: what are the links between the types and the concepts of the above natural number and the numbers mentioned in the Holy Quran? Well, the distribution of numbers they mentioned in the Holy Quran in different areas. So one can ask one question: are there links between these numbers mentioned in the Holy Quran? Of course there is, but it's difficult to find this link. So our lectures was talking about the weak numbers and the primitive weak numbers and the natural numbers in general. One can use these concepts for a future study or future research and can solve some open problems if we could. Thank you for listening.